Hello, and welcome to Learning Beyond Limits, where there is no limit to learning. Today we're going to talk about the number system. And the system that we want to talk about is the base 10 system. What is the base 10 system and why is it important? Why do we need to learn it? Well, long ago, when people would use math to talk about different things, let's say, for example, to represent an apple or two apples, three apples, maybe four apples, maybe, then people would use symbols like a stroke to represent one, two strokes, two, three, four. So, therefore, if you were to represent, let's say, 20 apples, then you would go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Who's That's a lot of counting. And that is just counting. Looking at it and decoding it would even be more challenging and take a longer time for you to look at so many strokes and say, well, it's 20. So there was indeed a need for a better way to get to represent numbers or represent a quantity in mathematics. The Roman system, yes, the Roman system came up with a solution to this. In Roman numeral, you would use this symbol to represent 1, and you add one more to represent 2, and add one more to represent 3. And if you were representing 5, you would use that symbol. And when you're representing 4, you would use that symbol. And so if you're representing 6, then you go use that symbol. And when you're representing 10, you use that symbol. And so you can see that with the Roman system, you would use less symbols to represent more. Well, this does put some solution to the problem that we had in the previous system, but the Roman numeral system was not a perfect system. One of the challenge with Roman numeral system was representing fraction in that system. Hence, there was the need for a better system, and the base 10 system comes into play. With the base 10 system, we had 10 symbols to represent numbers from 0 to 9. So now, if we want to talk about, say, one thing, we use the number 1 to represent, then two things, we use the number 2 to represent it. And unlike the Roman system, this system seems better because with the Roman system, if you want to represent two things, you would use two symbols. But when you're representing two things in the base 10 system, there's only one symbol representing that. So already you can see where the base 10 system is proven to be more efficient. Now note with the base 10 system, the largest single digit number that we can have is the number 9. So we can use this symbol to represent the number 9. And beyond the number 9, there is no single digit number to represent, say, for example, 10. So if, say, we wanted to represent, say, 21 chickens, then we would not be able to use a single digit to represent 21 chickens. So we could count up to 9, and when we get to 9, we would have to find some way of reusing these symbols, these 10 symbols that we have to represent up to 21. So this is what the solution is to that. Once you count up and get to 9, you are now going to figure out what to do next. So you know you can start over in the using your single digit. So you use 0, and using 0 would just be the same as saying 0 there. So you need to do something else. So you know that you have 10, so you put a 1 here to say, well, if you have 1 more than 9, then you have one group of 10. So you can see that grouping your values will help you to solve this problem. So if you use 1 to represent one group of 10, then that solves the problem. But note how similar that is using with the Roman system, how they had that symbol with this symbol to represent 5. And so how they did it was the position where the symbol is located in relation to another symbol gives the value. So the two symbols together with that position in mind gives the value. Similarly, with this base 10, the position, so this symbol here suggests the grouping, and this symbol still tells the unit value. So in future lesson, we will talk about place value, and you will understand that this is considered to be the ones column, and this is going to be considered to be the tens column. And so you can see the position where the digits are located will give the value or the meaning or the idea that it represents. So we see that using position value as in 2 and 1 helps us to count up higher than 10. Because with the base 10, we can only represent using the 10 symbols that we have, and the largest single digit we have is 9. So the key here is for us to understand how to use the base 10 system and why do we need to use it. You will recognize that everything that you do in math is built upon the base 10 system. Now, the interesting thing is, let's say the system that was used was a base 5 system. Yes, the system used could have been considered or could have been a base 5 or a base 6 system. But let's just say it was a base 5 system. Then the digits or the symbols that we'd use would be the symbols that I've just highlighted. Therefore, we'd count up to 4 from 0, 1, 2, 3, 4. And then if we want to represent one more than 4, then we would have to go 0 and use 1 to represent one group, and that group, because we're using the base 5, it would be one group of 5. Like when we were doing from 0, 1 straight up to 9, because we were using the base 10 system. When we got to 10, we were using this one, would have represent one group of 10, because it was the base 10 system that we are referring to. So understanding this is key to understanding the base system and why we use them and how they help us to communicate in mathematics. The next video, as I said, that I'll be posting will be the video of place value. So please press like to like this video, and if you have any suggestion, please leave it in the comment below. Also, if there's anything in concept in math that you would like me to take up, leave it in the comment below and I will create a video for that. Remember, this is Learning Beyond Limits, where there is no limit to learning.